Welcome to this week's Swarf and Chips 10-minute topic. We're here at R&G Precision in Wellingborough, and Enzo is going to give us an education on how he has made his machine shop more efficient and ultimately more profitable. So coming up in today's show, we're going to consider fourth axis machining, fifth axis machining, tooling, coolant, swarf. If you want an education, make sure you're watching today's 10-minute topic. Enzo, thank you for letting us into your facility. We've got a lot of ground to cover. So let's start off with lights out running. What does it mean to you and your company?
Well, lights out running obviously is something that we're moving forward to. It takes a lot of thinking to do, but it's so beneficial for the company because you can then get your larger batch work, larger orders, scheduled orders from your customers. You're gaining because your machine's running, they're gaining because you're manufacturing at a lower cost. So hopefully by doing that, they'll give you more work and everyone's happy. And yeah, the equipment's expensive and everything's expensive, but it will pay for itself in the end so quickly. It really is the way to go forward.
So let's talk about the things that you need to consider when you're talking about lights out. Okay. And how do you look at work differently? And we're going to look at some of the machines, we're going to see some of the work holding as well. So what are those things that you have to go, right, lights out, what am I looking at differently, how can I make this more efficient?
Okay, so firstly you need the quantity, and by that I mean you need the customer to give you a quantity of work, because if you've got like 20, 30, 40, 50, yes, you can run lights out, but you'll be done in an evening.
Yeah.
Or if you haven't got the quantity and you haven't got the cycle time, you won't be running all evening. You'll be running half the evening. So the first thing you need to do is consider the work, identify the work that will say, yes, I can run X amount of those, that will give me 24 hours.
Yep.
Okay?
Does the work have to be exactly the same? Is it repeat work or variety?
No, I mean, we're mixing and matching.
Right.
We predominantly keep the same material, so aluminium, so we don't get mixed swarf, because that's a big problem.
Okay, obviously. That's something to consider.
Yeah, that's a big problem. But it's just the timing. You need to have the hours, because you don't want to come in and it's not running, because that's defeating the object. So you need to have the hours where you would normally be still. So it could be 8 hours, could be 12, could be 24, whatever those hours would be. If you put enough work on so that it covers that, that's efficient lights out machining. Right, so secondly, another important thing you need to consider is proving the job out during the day. The last thing you want to do is load up a pallet or a cube or a pyramid with parts, go home, run lights out, come out, and obviously they're all scrap because either your tool's broken, your offsets are wrong, or anything like that. So very important that you prove the part out during the day, from machining, your tooling and everything, and also inspection. So prove it out during the day. Once you've proved that during the day, pass it on to nights and lights out. So that's really important on that.
Okay, I want to cover some of these a little bit later on in the show as well. Okay. So what's the next thing we need to consider?
Tooling.
Right.
So if you follow me.
So how many tools have you got on here?
So this machine has, I believe, now you're going to question me.
90?
90 tools.
Yep.
So if you imagine proving the job out during the day.
Yes.
The second most important, or third most important thing, I should say, sorry, is tooling. Now, what happens if you're running a job, it's done the first job out of 40 and the tool breaks?
Right.
You need to ensure that alongside a primary tool, the machine knows where its sister tool is.
Yes.
That if it breaks, in the program, it'll put that one back and it will take the sister tool out. What happens if the sister tool breaks? The machine needs to know that that part there goes to one side.
Right.
The whole job goes to one side and it picks the next job up.
Of course, because then you know you've been kind of had it flagged up to you.
Exactly.
Come back to it at a later date.
So obviously you've got 90 tools in there. You've probably got 3 or 4 different jobs, 20, 30 tools per job. So if your primary and sister tool breaks on one job, the machine parks that whole pallet of those jobs to one side and it picks up the next job.
You're not losing time.
You're not losing
You're not losing any time. Right,
okay.
next area we need to
coolant.
consider. Right.
So coolant, Again, very important that you've got obviously your spindle coolant, your through coolant, your wash down coolant, so you've got no swarf anywhere. Obviously the slides can alarm out if you've got coolant stuck in there, so you need to make sure that at all times you've got coolant wash on and it's full, that your tank is not clogged up, that it will stop the coolant from coming out. So that's really important as well, obviously.
Is there anything else?
Inspection. You don't want your inspectors to come in the morning and have a load of parts to check. So we facilitated here a brand new inspection room on the shop floor with a CMM in it, that the operator can literally take the whole vice off with the pallet, put it on the CMM that's ready set, press the button and it checks it 100%.
Well, that's all well and good and very easy to say when you've got a multi-pallet machine, but what about your vertical machining centres? Can you replicate all of what you've just said, but on those machines for other people?
Well, actually, yes. I just thought of a solution for that this morning.
So you brought me over to one of your 5-axis FANUC Robo Drills. In fact, it's your 15th FANUC, which is amazing. So what were you trying to explain then?
So if you have a look at the moment, we're running a customer component, which is one at a time. So we're doing OP1 on the 5-axis and OP2 in the vice. And that's a total runtime of an hour. And we've been doing that now for the last year and a bit.
Okay.
Moving forward and looking at lights out machining and the possibilities and work holding, I will show this porcupine or pyramid, if you like.
I prefer porcupine.
Where actually that will fit on the 5-axis, and with extra long reach tooling I can turn one at a time into 8 at a time, and suddenly I have 8 hours of runtime.
So you can reach all faces.
Indeed.
On this,
yes,
just by compensating and looking at
because of
tooling?
the size and extra long reach tooling. So you replicate that program 8 times, you'll put that on when you go home at night and it's running lights out.
So basically you're telling me something that you've been doing for the last year and a half, in fact, only this morning you've thought, why can't we improve on that?
Yeah.
Less people standing here at all times, and then that machine, that spindle is turning.
Exactly.
So you brought me over to your brother machines, you've got 4 of these, and they're all 4th-axis machines.
Yeah, exactly. And you asked the question about replicating lights out on a 4th-axis machine. Yes, you can. Simply, what you would do, and is what I've also told my guys to start looking at, is to replicate what you've got on top of the bridge plate underneath. So suddenly, by lifting up your bridge plate into the center of the axis, you can put work on top and on the bottom. So you go from 4 to 8 immediately with not much extra work, and just by replicating your program.
Again, another way of making a machine shop efficient. So you're talking about your 3-axis with the 4th-axis table, you've got 5-axis and your multi-pallet machines.
Yeah.
Wow, and I mean, looking at most of the machine shops around the UK, everyone has got at least one of each of
exactly.
those.
It's just, as I said before, it's thinking outside the box and beyond the boundary and trying it. If it works, then
go for it.
Happy days.
Yeah. Right, okay, last but not least, I want to cover work holding.
Okay.
So we're back in front of the Matsura, and I think we've got about 30 parts here.
Indeed, yeah, correct.
But maximum, you can get 80 parts.
80 parts. If you've got 10 cubes with 8 components on each cube, that's 80 parts. You think that if you've got an hour cycle per part, that's 80 hours of work. That's 2 weeks, obviously, theoretically, that the machine can run without anyone going near it. So
when you put it like
phenomenal.
that, it sounds...
It is phenomenal. And what I wanted to do here is have a diversity. So I wanted the triad cubes, I wanted the WNT vices, I wanted the nick end sort of pyramid porcupine, but I'm also waiting for 3 Lang pyramids, which you can do 3 at a time. So my key for this machine was to have a variety of work holding on one machine, so you'll never run out of possibilities.
So, you know, you talk about long runs, but variety, and I think that's what people are kind of hesitant with.
Yeah, exactly.
It's just incredible to see. This is engineering at its best, because you're kind of thinking outside the box. Literally, only this morning when you were talking about that as well.
Yeah, your mind just wanders all the time, and once you've put in that frame set of lights out machining, you start looking everywhere. Not everything's possible to do, but if it is, the guys will do it.
But it's transforming your machine shop. So for anybody, just to kind of finish off, for anybody looking to kind of work in a different way, What is lights out machining, making it more efficient in, with what you've told us, going to do for you and your business?
It's gonna increase our profits and our turnover, and more importantly, increase our customer relationship and our customers as well, because we can now go out and sell ourselves as an automated factory, and that's what they love. That's what they want to hear going forward. That they're going to get the best price possible and the best quality possible, and they both go hand in hand.
There you are, a win-win situation. Thanks for watching this week's Swarf and Chips. Don't forget to like, comment and subscribe. And as Enzo says,
with the right automated process, you will keep those spindles spinning.